lecture number 9, Dalton's Law of Partial Pressures, mole fraction. Okay, so this is just an extension of Dalton's Law of Partial Pressures. And we're going to bring in something called mole fraction. So in Dalton's Law, we're still looking at a mixture of gases in a container. So we're still going to have gases exerting a pressure. Okay, in a mixture of gases, we're going to have multiple different types of gases. Okay, so Dalton's Law of Partial Pressure says that we can figure out the sum of these gases equals my total pressure in the container. Okay, well we can also, if each of these is an amount of something, so let's say we have an amount of oxygen and an amount of nitrogen in our container. Okay, that relationship, the amount of something, we know in chemistry we refer to that as the mole, we can do that relation directly to pressure. Okay, so Dalton's Law for mole fraction is represented by something called an x, and we do x of whatever we want. So let's say we're solving for oxygen. So let's say that x of O2, which is our mole fraction, equals the mole of our gas divided by the total of our gas. Okay, so Dalton's Law of Partial Pressures is still that the P total equals the sum of all pressures. Okay, so we're going to relate this back to mole fraction. So here, if our mole fraction is the mole of our individual gas divided by our N total, we can also say that that relationship is going to be the same for pressures. So the pressure of our gas divided by our P total. Okay, the important thing is to find the pressure in a container, say if we're only given the amount of something, we can say that the partial pressure of whatever we want to solve for, here we're doing oxygen, will equal our mole fraction times the total pressure. Okay, this is going to give us our partial pressure of our individual gas. So let's say we have a scuba tank, and the scuba tank is going to exert 204 pressure, so 204 atmospheres. Okay, and we say that we have a 100-gram sample. Okay, so it's going to contain, and in this sample, we're going to be looking at two gases in this scuba tank. We're going to be looking at oxygen, and we're going to be looking at nitrogen. So let's say that I give you that 9.6 grams of this is oxygen. So we have 9.6 grams of O2. Okay, and we want to know what is the partial pressure of oxygen. Well, first I've got to figure out what is the aggressive amount of my other gas. So my other gas in here, we're going to have nitrogen and we're going to have oxygen. So in order to do any relation to pressure, remember Dalton's Law, we can relate pressure to the number of moles. So I've given the amount of oxygen, which I need to get to number of moles, and I also need to figure out the amount of nitrogen I have. So if I take 9.6 grams of O2, we convert that to moles. Okay, so this is going to be 32 to 1 mole. This is going to give us 9.6 divided by 32. We're going to get 0.30 moles. And here, if we have a 100-gram sample, and it's just oxygen and nitrogen, the leftover gas in the container must be nitrogen. So 100 minus 9.6 is going to give you 90.4 grams of N2. Okay, we need to do the same thing. We need to convert this to moles. Okay, so we're going to have 1 mole, and we're going to have the mass of nitrogen, which is 14.01 times 2, so 28.02 grams of N2. If we punch that into our calculator, we get that there are 3.23 moles of N2. Okay, so we have a lot more nitrogen than we do oxygen. Okay, so first thing we need to do though is we need to figure out what the total is here. So we're going to take 0.3 plus 3.23, so our total number of moles is 3.53 moles. This is our N total. Okay, well, I need to first get my mole fraction. We already know the total pressure of the container. This is my P total. Okay, I need to get my mole fraction of just oxygen. So we know that mole fraction is going to be the amount of moles of what you want divided by that total mole. We have the total in the container. So the moles of oxygen is 0.30 mole of O2, and we're going to divide it by the total. Okay, we also, in order to find the partial pressure of oxygen, we have to multiply it by the total pressure exerted in the container. So the total pressure is 204 atmospheres. Okay, my moles are going to cancel, so I'm going to take 204, multiply it by 0.3, and divide by 3.53. So if we do that, 0.3 times 204 divided by 3.53, we get that the partial pressure of oxygen is 17.3 atmospheres. Okay, and if we know the partial pressure of oxygen, I know the total pressure of oxygen, we also can determine the pressure of nitrogen. Remember, Dalton's law is that the total pressure equals the sum of the pressures of our gases. Okay, so in conclusion, in Dalton's law, if we're not given the pressure exerted by each individual gas, but we know the amount of the gas, we can determine the mole fraction to figure out the partial pressure.